Now we want to start to look at the idea of velocity and acceleration. Now, we've been doing rates of change, and really, if we break it down, velocity is a rate of change. Velocity is often called speed. But it's really a little bit it's the same but a little bit different, if you get the meaning. Speed is velocity is speed, but in a given direction. So either in a positive direction or a negative direction. So what we're looking at here is speed or velocity being the rate of distance over time. So how fast a car is going is basically how much distance is it covering in a certain particular amount of time. So if we're looking at what a car's speed is, we're looking at its velocity and it's going in one direction. If we look at going in the other direction, it's still a speed, uh, but it's just going in a negative direction. So if you do, velocity and speed are different in that regards. Basically, speed could be velocity without any signs. So we can look at it that way. Acceleration is how much the velocity is changing, or the rate of change of the velocity. So over time. So there's the relationships that exist. Mathematically, what we're looking at is the velocity is the derivative of x with respect to t, or the derivative of the function of t, if we're starting with x is the function of t there. So we can write it a number of different ways. Or acceleration is dv dt, or d squared x dt squared, or f double dash t. One that we haven't included here, but we probably should, that we'll see, is velocity could be written as x with a dot above it, and acceleration is x with two dots above it. So remember that this is all derivative with respect to t, with respect to time. It's all the rate of change is all about time, how things are changing over time, whether it's the distance is changing over time or the velocity is changing over time. So get used to seeing any of those notations and realizing if it's velocity or acceleration.